In this video, we're going to take a look at the different angle pair relationships and how they relate to each other. In these first examples we're looking at, it's important to note that these lines are parallel as indicated by the red arrows. So let's go ahead and look at this first angle pair relationship, alternate interior angles. Alternate interior angles are angles that are on opposite sides of the transversal, one on the left, one on the right, and they are in between these two pairs of red, or the two parallel lines that are indicated by the red arrows. So looking at these here, alternate interior angles have measurements that are the same. So I would know that these pairs of angles with the blue arcs are congruent, as well as my angles with the green dots here would be congruent to each other. The second angle pair relationship I want to look at is corresponding angles. Corresponding angles are angles that are in the same position in relation to the transversal and the parallel lines. So in this first example of corresponding angles, they're in the lower left-hand quadrant where the transversal and the parallel lines intersect. So they are below the line and to the left of the transversal. In this second example here, they are above the parallel line, but still to the left of the transversal. When lines are parallel, corresponding angles are congruent or have the same measure. Another angle pair relationship we can study is alternate exterior angles. Similar to alternate interior angles, I want one on the left and one on the right of that transversal. But this time they are exterior of those parallel lines, so they are not in between, they are on the outsides of those parallel lines. Again, just like the others on this slide, alternate interior angles are congruent or have the same measure when lines are parallel. Another relationship that we'll frequently see is vertical angles. Vertical angles are defined as angles that are opposite of each other when two lines intersect. We know these lines are congruent, these angles are congruent as well. As I study angle pair relationships, not all relationships are congruent, but when lines are parallel, alternate interior, alternate exterior, corresponding angles are all congruent. And then I also know that vertical angles is a congruent relationship as well. Let's take a look at a couple relationships where the measure of the angles are supplementary. So when I look at a straight angle pair here, I know that these two angles have to add up to 180 degrees. Therefore, we say they are supplementary. Okay, when I look at same side interior angles, if I were to copy this angle and trace it, slide it up here, it would make a straight angle pair. So if I call this X and Y, when I translate X up, it would end up here. And again, I would know X and Y would have to be supplementary together. So same side interior angles are supplementary. Again, this is when lines are parallel. I have these arrows here indicating that these lines are parallel. And then the last relationship I wanted to point out is one that we are familiar with. It is a triangle sum theorem. I know that if I add the angles in a triangle, they would all add up to 180 degrees. So now I just need to apply these various angle pair relationships to solve for unknown variables. In this case, I see that B and 22 are vertical angles, so I can go ahead and mark that B is 22 degrees. I also notice that C and A are vertical angles, so as soon as I find one, I know the other is the same. When I look at A and 22, I see that they make a straight angle pair, so I know that A plus 22 has to equal 180 degrees. So when I subtract, I believe I get 158 degrees for A, and then C would be the same because they are vertical angles. Let's look at this next one here. In this case, all I see is this straight angle here, so I would write my equation 5x plus 12 plus 68 equals 180 degrees. And then I'm just going to use algebra to solve from there. And then moving on, I'm going to look at this one with parallel lines. Now I have two lines that are parallel with those arrows cut by a transversal, and it looks like these two angles are alternate interior angles. So they are on opposite sides of the transversal, and they are on the interior of those parallel lines. So I know alternate interior angles are congruent when lines are parallel. Since I know that they are congruent, I can write an equation in which I just set them equal to each other and then solve. my algebra steps. To get my answer. All right, then let's take a look at this triangle one here. Now I have to find angle X, but first I need to find this angle here in red. I know that the angles in a triangle add up to 180 degrees, so I can find that angle by taking 180 minus the 23 minus 58. When I do that, I get 99 degrees for that missing angle. Once I figure out what that is, I can use the fact that I know that these two angles here have to make a straight angle pair, and I can say that x plus 99 equals 180. And that allows me to solve and get 81 degrees for x. Each one of these problems is a little bit different, but you'll still have to either figure out, are the angles equal to each other? Do they add up to 180? In this case, these are angles in a triangle, so I'm going to go ahead and add them together. 5x plus 2x plus 1x is 8x. And then combining like terms with the 13 and the 7, I know all my angles on the inside are 8x plus 20 when I simplify them, but when I use the fact that they're a triangle, so they add up to 180 degrees, that gives me an equation that I can write and then subsequently solve. So these are just a variety of the different angle pair relationships you will use throughout this unit and this course to find values of the variable. Last one here. Again, I have a triangle. This time the triangle is isosceles. Because the triangle is isosceles, I know its base angles, the angles that are adjacent to those corresponding legs or congruent legs are congruent to each other. So I'm going to go ahead and say 3x plus 20 equals 5x, because with that isosceles triangle, I have a line of symmetry that runs down the middle. So then that gives me an equation that I can solve rather quickly. So again, you're going to want to make sure you know those angle pair relationships that we went over at the beginning, the corresponding same side interior, alternate exterior. Know those angle relationships, study them, so that way you can recognize when to apply the different relationships.